Yeah, hi there. I wrote a little program called JPEG hide recently. So I'll be doing videos on the programs that I write because it's kind of pointless if I just write it and just upload it into my GitHub, and it's kind of useless. So whatever. I'm gonna show how it works and how you can use it to hide files into images, but not just only images. You can actually hide whatever you want into those images, and so my Visual Studio takes a while to load because of the resharper thing. And yeah, this is the program. Here we're doing some basic input-output stuff. Nothing to explain really. However, here we have our hide file and discover file. And the thing that it does is it takes all the bytes here. I'll just explain the hide file first because it kind of has an order. When you do want to hide a file into an image, for example, JPEG image, you want to hide the text file into an image, it takes the bytes, reads all the bytes from the image that you have, turns it into a list because you'll want to add some stuff later on, and you have to do the same, read all the bytes for the file that you want to insert and hide into that image. So you do that here too. And LZMA, this is a compression. It's a really cool compression. I like it a lot, especially when you're compressing text files, because the thing that it does, if you have the word computer 10 times in your text file, it just says, okay, here's the word computer, okay, instead of repeating it 10 times, it just keeps the word computer up there and says, okay, so you have to put the word computer in place A, B, C, D, wherever it might be in your file. So it reduces your text file size a lot, and you can actually use it for some programs too. For example, C# programs have that I'm compiling just natively, just in Visual Studio and stuff. Usually they have a lot of useless stuff that is not useless but can be compressed, but it's not by default. So whenever you are like your program is, for example, 100 kilobytes, you can compress that into like sub 50 kilobytes because most of it is just like space, and you can say, okay, here's the space, like repeat it all these places and just, you know, do the thing. And for example, your paths, like you have to say system.io.file instead of the whole thing repeating it like 30 places in the file. You just keep that, it keeps it up there and repeats it wherever it's needed. So LZMA2 actually, it's real cool. If you just want to use it or do some experiments with it, you can, the 7-zip has it, like you can, for example, like we have this here, you can do, okay, you can't see that now. Okay, 7-zip add to archive. Okay, so compression method you have here, LZMA2 or LZMA. I don't know what's the difference between them. I just use LZMA2. And for example, the file is 10 kilobytes here, and now if I compress it under LZM82 compression level ultra into a 7-zip file, let's see how it will turn out. Okay, like it's 1 kilobyte. You see what I'm talking about here? Let's see what's in here. I actually don't remember. So yeah, I wrote a crawler. So see, all of this is repeating 36 times. Instead of just doing that, it says just this is the word, repeat it 36 times in these different places. And that's how you get 10 kilobytes down to 1 goddamn kilobyte. That's huge. You have your whole file here back. Doesn't make a difference, and it is real fast. You can work with it. So, however, you have your file here that you have to insert. I decided to compress the file that you're hiding into that image because I mean, you don't want it to be too obvious that if you're opening it, I don't know, 3000 pixels by 3060 pixels image, and it's fucking 2 megabytes. You don't want that. So I'm trying to compress it how much I can. I mean, obviously I can't compress MP3 and MP4 files that much, but trying my best. Okay. So now you insert, now you compress the insert file, that is the file that you want to hide, and then we have a border here. This border is this, okay. It can be anything virtually, but you want to have it something complicated. Then the possibilities are tiny that it might be actually the same string in the image file, like whenever like you turn it into UTF-8. So you don't want it to repeat. I just this is a 64 character strong password. I just searched up in Google strong password generator, set it up to 64, and I got this. And this is the border. What the thing that it does is it says, okay, this is the actual image, and from this border, below this border, is the file that I want to read, and it will be the file that you hid into the image. So the way that JPEG works is it has a border for itself. It's, for example, it says like I start here, I set my EXIF stuff here, and these are my binary stuff, la la la. And after some point, I can show it to you. For example, if we take an image, okay, like let's take this. Okay. Okay. So as you can see, here's this. Every JPEG starts with this Yoya kind of thing, and then there is the EXIF, and here is some information about the program, Photoshop 2018. This is the time, and actually you can insert whatever you want after this line, and it won't make a difference. But I didn't do that because whenever I add the image, the file that I want to hide into that image, at the end, it works with PNGs, it works with, I don't know, TIFF files, MP3 files, even WAV files, MP4, everything. It just works because they all know where the data starts and where it ends. So I don't have to like just find the sweet spot for every file. So it just happens automatically. So if you look closely here, this is big fucking file, and okay, from here on, okay, it doesn't matter what let me do this. Okay, this is here, and I got this here. Okay, I can, okay. So now, if I save this, which I did, you see the image is still there. No matter what I add here, it won't make a difference. See, it loads again, no difference. So, okay, there's that. But however, if I add stuff here and save it, see this, it messes up the image. So we don't want that. And actually you can do some like weird glitch stuff. You can write a program that just inserts random bytes into random places, and see, this messes it up. But however, you don't want to mess with this part, because if you mess with this part, if I just hit that, I just do press and enter, see, the whole image just loses its mind, doesn't know what to do with that one enter there. So it's the same here. I can do this, and well, that didn't do much. It's here from up this part. If I add something here, yeah, it will break. We don't want that. So, and you can actually like edit this to like whatever you want, your name. Like, it won't make a difference. Well, it fucking did. I don't know what I expected there, but it made a difference. I don't know how it's dependent though. It's a string, Adobe Photoshop CC 2018. What if I make this 2017? Well, it works. I don't know like how actually JPEGs work deep that level, but as you can see, it broke the image. So whatever. Moving on. So if I enter yeah, it breaks the image. So you don't want that. No, yeah, okay, fine, just works. So it's the same with PNG files. This is the same image, but it's PNG. So if I add this here and preview, this is a huge file too. Like, just my computer has some problems with even. Okay, whatever. This is PNG here, and I didn't actually try. I didn't do experiments on the PNG, but I assume it has to work the same way. A little bit different, not much different. Okay, for example, add here blah 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 and put save. Well, you see the bottom part just is gone now, and it's back. No, I messed up something here. Okay, now it's back. So, but the same for a PNG file. If I get the last character here and say hello, like my computer is just freaking out. I'm just recording a simple thing. I don't know why it does that. So, as you can see, nothing actually changed in the image, because it knows where its own data starts and where it ends. So it won't care if you add anything below that point. But however, for me to not define every ending point and every ending bytes for every single file, I just add my own border here, which is this. So now we know how that works. Let's go on. So as we're just working with bytes here, I'll need to get the bytes from border, and I'm just working UTF-8 because that's the standard, but it doesn't make a difference. But I have to use the same encoding in the hiding process and discovery process, so I can actually read it truly without any problems. And then I add range, which is you add another array of bytes, like to your main image. That's exactly what you're doing here. And yeah, you have your image, you add the border to image, and then the compressed image, the compressed file, and you return it as an array, which is basically the bytes of your file. And yeah, as you can see here, I'll be writing all those bytes to destination path using the data that the hide file gave me. And it's the same for discovery process. So first I will need to get all the bytes for my image, and then I need to find where's the border. So I have a index of thing here that finds, it takes an array to search through and pattern to find, and the pattern to find is the bytes of this border, and it finds the index. Okay, now we are at the beginning of the border, so is the border included? So we have to, as its index is just showing an image, like it's showing just a digit, a location on the file in the bytes array, sorry. We have to add how much the length of the border itself is to the index to go to the beginning of our real file. So we get the index. How much is the index? Okay, our file starts from there, and we don't care where it ends, because the end of the file we know what we wrote to the image. So we have the image here. We have to skip this much, like how much this is, and then we actually have our file that we hid into the image, or the file, doesn't matter. And now we have our thing here, the hidden file, and we have to give it back as an array, which that's what I do here. Yeah, discover file, base image, get the data, write all bytes, and file created. Okay, let's see how all of these work. So for example, let's open up its own repository here. Okay, this is real simple stuff. Like, just didn't have enough time, and I'm not good with UI, so I just did this little thing just so it works. It's not just a, I don't know, useless code. So okay, F1 for hiding. Now we want to hide. Let's see some breakpoints here, so I can show you exactly how it works. Enter base image path. Okay, the image that we want to hide something in it. Actually, let's get a fresh image. Let's go to Reddit. Okay, let's get this. This is sorry, I got distracted. All those Reddit memes. Can you give me a real JPEG file? What the fuck is it? WebP. Okay, so it gave us PNG file. It doesn't matter. So here's our file. Okay, pass it on. Enter the code file path, which is the file that you want to hide into the base image. So what should we give it? Like let's do this, or yeah, this is good. Okay, we want to hide the MP3 file into the PNG file. Okay, enter destination file path, which will be, as it's in PNG, let's give it same it is, add another 2 here, and okay, here it comes. Okay, so it's reading the image. Okay, it's this much bytes, and our mp3 file is this much bytes, and pass an array and insert 22288. Okay, so as you can see, we decreased the size of the mp3 file just a little bit, not much. It was 2228888, and it was like, now it's 1400. Doesn't matter. So the image is now 3593, 3594, and 37. The size increases, and we pass the image back, and it writes all the file, which is this one, and see, it's just a regular image. You can't tell a difference between this and this. Nothing is like, no color changes, nothing. You know why? Let's figure out why. This is my other Notepad++. Actually have it in this one. Okay. Oh my fucking god. No. Okay, I told you to close all the things. Okay. Fine. We have this and we have this. Let's run a compare on it. Okay. So as you can see, above this line, which, see, above this line is the JPEG file. We didn't touch it at all. As you can see here, nothing's changed. After this point, which I assume is the border, but I can't read it because I don't have that skill to read binary files in, I don't know, in UTF-8 or ANSI or whatever it is. And this is our mp3 file. As you can see, it's all empty here. There's nothing there. This is our mp3 file, and that's the difference. It's after the point that the actual file is. So let's go on. I can't do it because I'm stuck here. So let's do the same for discovery file. Okay, discovery, base image path. This is the image that we hid the file in it. Okay, destination file path, which will be the answer.3. Okay, man. We load the image. We find the index, which is 359361 bytes in. So we go on, plus the length of the border, which is 64 bytes, and we skip that amount. Like if image is this long, we want to skip this much of it to get our real file. I know I'm just repeating myself. There might be some people watching this that might not understand the language truly, so I'm sorry if I'm boring you. And now we have our hidden file that is there. So we pass on the bytes. Okay, this is our mp3 file here, and we write it to the destination path, which is mp3 Okay, if we, as you can see, it works. So it's the same mp3 file. So that's it, I guess. There's not much because it's not that complicated. And the source code is up to GitHub, the GitHub page. Which I'll post a link below. And yeah, this is it. And I have some notes here that it will work with any kind of file as a base file. The base file is the file that you hide another file in it, and the code file is the file that you're hiding into something. And the program will work virtually on any file, as base file or code file, doesn't matter, as long as your base file knows its limits, and it doesn't take the length of the file as it's whatever data there is, just to read it and try to decode it, kind of thing. I don't know of any file that does that besides the text files. Even Word documents don't do that. Although, like, there's some shitty Word kind of things. What it was, Word did what? Rich text document. I don't know how that works. I assume it's a. Just another zip file. If you didn't know, Word documents are actually zip files. So no, this one isn't. So whatever. You can try on those. I didn't try. I tried on PNG, TIFF, MP3, WAV, MP4, and that kind of stuff, and it worked. But you're free to just try on those files, and if there's an issue, you can just open up an issue here, ticket on the GitHub. So I'll just try to fix that so it works with every file. And however, it will work with text file, as I wrote there. It will work with text files, but the problem is that you want to hide it. You won't be able to completely hide it, hide the fact that your text file is just an innocent text file, because it will have all this gibberish above the line of the actual text file, because text files work that way. Just they read whatever that is. That's why you can just open any file in Notepad++. However, there's some different reasons for that, but you get the idea. So it's not just for JPEG. You can hide any file in any other file virtually. So that's it. I'm not going to make the video any longer because there's no point to it. If you want to get the binaries so you can try it yourself, you can just download this zip file, not these. If you want the source code, you can get the source code and compile it in Visual Studio. But if you just want to try it out, you can download this one, and as long as you can remember, it's an exa file and a 7-zip library with it, whatever. And yeah, you can download it here at github.com/TheBitBrine/JPEG hide/releases if you want the releases. And yeah, I have other cool stuff here too. You can check it out too. But if it's important enough, I'll make some videos on it. Like the Spotify recorder, I made videos about it, so it's up in the GitHub, up in the YouTube, sorry. And I'll post the link to this down in the description, so if you want to check it out. And yeah, that's it. Thanks for watching.